Let's take a look at number 4. What would I need to do first to solve? Add 3 to the other side. So tangent squared is equal to 3. What would I do next? Square root both sides. So tangent is equal to what? Plus or minus square root 3. Don't forget, if you ever take the square root of both sides, you need that plus or minus. So tangent tells us to look at what on the unit circle? Y over x. So I'd have to go to my unit circle and figure out where y over x is positive square root 3 and negative square root 3. So 2 different values. I think, if I were to guess, that it's going to be pi over 3. But our point at pi over 3 is 1/2 and square root 3 over 2. The unit circle is going to be given to you, so use it to help you with the review. So this would be square root 3 over 2 over 1/2. This is our point. This will be given. This is a unit circle. We're looking for tangent, which is y over x. So I put the y over the x. Trying to see which one gives me the square root 3. So this one would be square root 3, the pi over 3, and it's positive. So looking at your unit circle, have a unit circle with you, but my answers here are going to be pi over 3. It will be 2 pi over 3. 4 pi over 3 and 5 pi over 3. Because these are all the values on our unit circle where we would get a positive square root 3 and negative square root 3 when we do the y over x. So you have to do y over x to figure out which one gives you the square root 3. And we care about the positive ones and the negative ones. So whenever it's tangent, you have to find what y over x is. Figure out what your first 3 are. When you find which one matches, you want to look and see whatever your denominator is, it's going to be the same as the denominator. Notice how all of our answers had the 3 on the bottom. So it'll be the same as the one from here. So if our answer matched the one in the middle, which is pi over 4, then we would look at all the ones that have pi over the 4 on the bottom. But it was this one. Use the unit circle. I know my drawing of the unit circle is not very helpful, but use the unit circle. Just find one on the internet, put it on your review to help you. Or you can find one from the notes. Find one from the notes then. All right, let's take a look at number 3. What should we do first? Perfect. So we can change this to be tangent squared. What else can I do? So I can make it 1 over sine squared and sine squared over cosine squared. Cancel out the signs. So this would be 1 over cosine squared, which is secant squared. Perfect. So we're done. Let's take a look at 5. What would we do to solve 5? I can move the 2 cosine. Doesn't matter which way we move it. I guess I'll move the one on the left. So subtract 2 cosine. So I have 4 is equal to negative 4 cosine. Because these are like terms, so I can combine them. What should I do next? Divide by negative 4. So I get cosine x is equal to negative 1. Cosine tells me I have to look at what value? The x value. So I'm looking at the x value on my unit circle, that is negative 1. So where's x negative 1? Pi. Is that it? Yes. So x is equal to pi. For all of the solving questions, it'll say on the interval from 0 to 2 pi. That just means one time around the unit circle. Okay. So your answer is going to be something on the unit circle. What if, let's say, we had a unit circle and our answer was, let's say we were looking for cosine of x is equal to 1. So that would be this. Would I pick 0 or 2 pi here? If my interval was from 0 to 2 pi. Because remember, 0 and 2 pi are the same, but which one would I pick for my answer? 0, because 0 is included. So we'd pick 0. So if your answer happens to be at 0 degrees, it's 0 and not 2 pi. All right, 6 is super. All right, I'm going to go back through and do all the ones that we didn't do in class. So looking at number 1, I see that I have my Pythagorean identities here. 1 minus sine squared would be cosine squared, so I can take that out, replace it with cosine squared. Secant squared is 1 over cosine squared times the cosine squared, which would actually just cancel out and become 1. So 1 is equal to 1. Number 2, again, I see that I have a Pythagorean identity that I'm probably going to use. Cosecant squared would be, cosecant squared minus 1 would be cotangent squared. And we said that this should be a tangent squared. So when I have tangent squared times, I know cotangent relates to tangent. It's the reciprocal of it, so I can make it 1 over tangent squared, which I can cross out my tangents. So I get 1 is equal to 1. All right, next let's look at number 6. I have 2 signs here, so I know I'm going to want to combine my like terms. So I can subtract 2 sine, move it to the other side. So I get 2 is equal to negative 4 sine. Then I divide both sides by negative 4 because we want to get that sine all by itself. So I have sine of x is equal to negative 1/2 because I just simplified my fraction here. So I'm going to go to my unit circle. For sine, I need to look at the y values. So I need to see where my value is negative 1/2. So that would be at 7 pi over 6 and 11 pi over 6. So these would be my 2 answers. 10 is a good one. Let's look at 10. Now we are solving. I have a term that's squared and another one that's not. So how do you think I need to solve this? Okay, so I'm going to change it. Perfect. So my trig function sine squared plus cosine squared is equal to 1. This will be given to you too, your trig identities. So to figure out what sine squared is equal to, I know sine squared is equal to 1 minus cosine squared. So I'm going to take out this sine squared and replace it with the 1 minus cosine squared. So I have 8 times 1 minus cosine squared x minus 11 is equal to 10 cosine x. What do you think I should do next? Distribute, and we can move the 10 cosine to the other side too. So I'm going to distribute that 8. So 8 minus 8 cosine squared minus 11 minus 10 cosine is equal to 0. What else can I do? Combine like terms, and I'm going to put it in standard form. So I'm going to combine my 2 constants there and make it 8 cosine squared x minus 10 cosine x. And this would be minus 3 is equal to 0. Before I do that, anything else you think I want to do first? I can multiply or divide everything by -1. You just have to be really careful with your signs when you multiply the first times last and go back in and divide, because one of them will simplify to be a negative in front of the cosine, the other one won't. Because you want to make sure whatever you FOIL, you end up getting this back out. But it just is very helpful. Just divide everything by the -1 and get rid of it. So I have 8 cosine squared plus 10 cosine plus 3 is equal to 0. Now again, if you didn't do that, you just have to be careful. You'll end up with the same answer if you do it right, but it's just going to be a little bit more work in the middle. Now what can I do to factor? Multiply the first and the last. So 8 times 3 is, do I have two factors of 24 that add to 10? 6 and 4. So this would be cosine plus 6 and cosine plus 4. What do I have to do next? Divide by 8. So since we started by multiplying that 8, we have to remember to go back in and divide by 8. Simplify where you can. If you can't simplify, move it to the front. So can I simplify 6 over 8? What does it simplify to? 3 over 4. So the 4 would go in front of the cosine. So 4 cosine x plus 3. Do the same thing with the other one. It simplifies to 1/2. So the 2 would go in front of the cosine. So 2 cosine plus 1. What would I do next? Set them both equal to 0 and solve. So 4 cosine x plus 3 is equal to 0. 2 cosine x plus 1 is equal to 0. So the first one, we would subtract 3 and divide by 4. So cosine x is equal to -3/4. Second one, subtract 1, divide by 2. So cosine x is equal to -1/2. Now cosine tells us to look at what value on the unit circle? The x value. On my unit circle, is there any x value that is -3/4? No, so we can cross this one off. That's not going to give us an answer on the unit circle. If we had a calculator, we could figure it out, but you won't on the test. We're just working with values on our unit circle. So again, for the next one, I'm looking for my x value. Now I want to see where I have an x value at 1/2, at -1/2. Perfect, 2 pi over 3, so x is equal to 2 pi over 3. And said 4 pi over 3? Yes. Awesome. So these would be my two answers. So we're going to skip that one and let's do 9. So 9, we have the same trig function, so we can go ahead and factor. How would I factor this? Multiply the first times the last. So we need our two factors of 9 that add to -6. -3 and -3. So I would have sine -3 and sine -3. What do I have to do next? Divide by 9. So I'm going to divide both of these by 9. What would I do with that? Simplify. So this changes into 1/3 and this one also changes to 1/3. Now we can move the denominator in front of the sign. You're going to end up moving it back anyway, so if you wanted to keep it as a fraction, that's fine, but I don't know, it helps to move it. It's just an extra step though. So 3 sine x minus 1 and 3 sine x minus 1. What would I do next? Set them both equal to 0. So 3 sine x minus 1 is equal to 0. This one's the same thing. 3 sine x minus 1 is equal to 0. What's next? Add 1 and divide by 3. So sine of x is equal to 1/3. And sine of x is equal to 1/3. Sine tells us we have to look at what? The y value. So going to my unit circle, do I have a y value that's 1/3? No, so neither one of these work. That would be fine. On the test it'll work. Like at least one of them will work, but no solution's fine.
That wouldn't be like you would just. Well, I know it's not gonna be on the test, but it's just like no solution of anything.
Yeah. So this one, even if you left it from here and just showed me put an x through both of them, that's fine. So this one, it just so happens that neither one works. What should we do first for 12? I can move tan over. What else can I do? Divide everything by 8. Let's get rid of that 8. So it ends up being secant x plus tangent is equal to 1. And then we can move the tangent over, so subtract tangent. So secant x is equal to 1 minus tangent. Now, what do I have to do next? Square both sides. Awesome. We can't use one of our identities here because it's not squared, but we can make both sides squared. So this would be secant squared x is equal to 1 minus tangent squared. So this would be like saying 1 minus tangent times 1 minus tangent. And what would I have to do to square this? FOIL. You don't just distribute the squared, you have to FOIL. So that would be 1 minus 2 tangent plus tangent squared. So that's what you get when you FOIL it out. What can I do next? Awesome. I'm going to change secant squared to 1 plus tangent squared. What else can I do? Combine like terms. So I'm going to move it to the other side. I'm going to subtract 1 on both sides and subtract tangent squared. So I'm left with nothing on the left side. 1 minus 1 cancels. So I have negative 2 tangent. And the tangent squareds cancel also. Tangent squared minus tangent squared cancels. What would I do next? Divide by negative 2. So 0 is equal to tangent. Tangent tells me I look at which value? The y over x. So I need to figure out where y over x is 0. When you have two different trig functions, we need them to be the same. So like usually if one was squared, we would use our Pythagorean identities and change the squared one. But here neither one of them is squared. So we have to square both sides in order to make one of them squared, so then we can convert it. But you can't just square one without squaring the other side. What should I do first for 11? Factor. So what are two factors of negative 2 that add to negative 1? Negative 2 and positive 1. So we have cosecant minus 2 and cosecant plus 1. What would we do next? Set them equal to 0. So cosecant minus 2 is equal to 0 and cosecant plus 1 is equal to 0. So cosecant is equal to 2 and cosecant is equal to negative 1. So cosecant tells me I look at what? 1 over y. Yes. So is there anywhere where I have the 1 over y value of 2 on the unit circle? No. So we cross that one off. That one's not going to give us an answer. Is there anywhere where we have 1 over y as -1 on the unit circle? Where? Three pi over 2. Perfect. Awesome. So that would be our answer.
Can't 2 be like 1/2 and then it's 1/1?
Oh, true. Yes. Which was my point of why I did this question. So we have cosecant is equal to 2. If you want to, which I think it helps to think about it this way, flip both sides. So you would take the reciprocal of the left and the right. So this would be sine is equal to 1/2. So flip this and flip this. So do I have anywhere where my y value is 1/2? Awesome. Pi over 3 and 5 pi over 3. Perfect. So these would be my 3 answers here. I trusted you. 1/2, we're looking at the y value, so it'd be pi over 6. And is it 5 pi over 6? Yeah. Just be careful, because it would stink to go through the whole problem and then just make a mistake looking at the unit circle. So just be super careful with picking which number from the unit circle. Be careful with your signs. And yeah, just be careful. So next we need to look at our unit circle, figure out where our y over x values are +1 and -1. So going to our unit circle, if we figured out what y over x is for all of these, so for our first 3 in the first quadrant, we would see that for pi over 4, we would get square root 2 over 2 over square root 2 over 2, which would give us 1. So we know that it's going to be the ones with 4 in the denominator. So this one would be -1. This one here, 5 pi over 4, would be +1, and then 7 pi over 4 would be -1. So we're looking for +1s and -1s, so it would be all 4 of those. So we'd have x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. For number 8, we see that we have a term that is squared and not squared, so we're going to have to factor. So I need it to be equal to 0 in order to factor. So I'm going to add 3 to both sides. So 2 cosine squared minus 7 cosine plus 3 is equal to 0. Since we start with the leading coefficient that is not 1, we have to multiply the first times last, and we get 6. So our 2 factors of 6 that add to -7 would be -6 and -1. So this factors into cosine minus 6 and cosine minus 1. But we cannot forget, since we started with multiplying, we have to remember to divide. So we get cosine minus 3 and 2 cosine minus 1. So we would set them both equal to 0. And solve. So cosine x is equal to 3. Cosine tells us that we look at x values. On my unit circle, I do not have any x values that give me 3, so I can cross that out. You can find what the solution is using a calculator, but since we're not using a calculator for these, we would just cross it off. Next, we want to find 2 cosine x minus 1. So I'm going to add 1 to both sides and divide by 2. So cosine x is equal to 1/2. I need to figure out where my x value is 1/2 on the unit circle. So I would go to my unit circle. I see that x is 1/2 at pi over 3 and 5 pi over 3. So my answers here would be pi over 3 and 5 pi over 3. Right, 9, 10, 11, and 12 we did in class, so we can look at 13. 13, we have 2 cosines. So we're going to combine our like terms. Since neither one of these is squared, we know that we can add them together because they are like terms. So I'm going to subtract 5 cosine x, move it to the other side. So it cancels, so negative square root 3 is equal to negative 2 cosine x. Divide both sides by negative 2 because we want to get our trig function all by itself. So cosine x is equal to square root 3 over 2. Cosine tells us that we look at x values. So I want to see where are my x values, square root 3 over 2. So I'm going to go back to my unit circle. X is square root 3 over 2 at pi over 6. And 11 pi over 6. So x is equal to pi over 6 and 11 pi over 6. So those would be our 2 answers. All right, so looking at 19, what should I do first? Subtract the 3. Then divide by 3. What would I do next? I want to find where y over x on my unit circle is negative 1. So that would be at 3 pi over 4 and 7 pi over 4. Now, what's the last step that I have to do? Multiply both sides by 2 to get it to cancel. And I'm going to do that on both equations. So times 2, times 2, times 2, times 2. So I get x is equal to 6 pi over 4, which we would have to simplify to 3 pi over 2. And then x is equal to 14 pi over 4, which would simplify to 7 pi over 2. So these would be our 2 answers. All right, what should I do first for 17? So my trig function's already all by itself, so I just have to look at my unit circle and figure out what value is square root 3 over 2, the y value. Because sine tells us we have to look at the y value. So where is my y value, square root 3 over 2? Pi over 3. So I'm going to say 3x is equal to pi over 3. And where else? 2 pi over 3. So instead of it just being x like it was before and x equals, we have that 3 in front of the x. So I have to say 3x equals. Now, how would I get x all by itself? Divide by 3. So I'd have to divide by 3. So this is like saying 3 over 1. We would keep change flip. So it's like multiplying by 1/3. So this would be pi over 9 and 2 pi over 9. For 14, we are solving here also, but I have different trig functions, so I need to change the squared one using my identity to make my trig functions the same. So I'm going to change sine squared to be 1 minus cosine squared. So then I know I have to distribute the -2 to simplify. So -2 minus would turn into plus. So plus 2 cosine squared x plus 3 cosine plus 3 is equal to 0. Combine the like terms. So we have -2 plus 3, which would be 1. Be careful because they are on the same side. So you're not adding 2 to the other side. You just combine your like terms. So now I can factor. So my leading coefficient is not 1, so I have to multiply the first times the last. I get 2. 2 factors of 2 that add to 3 would be 2 and 1. So this would be cosine plus 2 and cosine plus 1 is equal to 0. Now we can't forget, since we started by multiplying, we have to make sure we go back in and divide. So divide both of these numbers by 2. Simplify if you can. So here we get cosine x plus 1 is equal to 0. And 2 cosine x plus 1 is equal to 0. So I skipped a step there. I just set them both equal to 0. Now I'm going to solve. So cosine x is equal to -1. And cosine x is equal to -1/2. Now cosine tells us that we have to look at x values. So I want to see where on my unit circle is my x value, -1, and that would be at pi, so x is equal to pi. And then I want to see where on my unit circle are my x values -1/2, so that would be 2 pi over 3 and 4 pi over 3. So these would be my 3 answers. All right, 15, we are solving. So we want to get our trig function by itself, which it already is. So I need to find where my x value, because cosine goes with the x value, so where my x value is -1/2 on the unit circle. We just did that in the last one, so that would be at 2 pi over 3 and 4 pi over 3. Now to solve, I need to get x all by itself. So since 2 is being multiplied to x, I'm going to divide both sides by 2, which we would keep change flip. So we get x is equal to pi over 3. And keep change flip again here. So we would get x is equal to 2 pi over 3. So these would be our 2 answers. 16, again, we're doing the same thing. We need to get our trig function by itself. We are going to save that 3x for last. So I'm going to move everything to the other side. I'm going to add 1 and divide by 2. So sine of 3x is equal to 1/2. Sine tells me that I have to look at y values. So I need to see where my y value is 1/2. So I have 3x is equal to pi over 6. And 3x is equal to 5 pi over 6. Yep, 5 pi over 6. Since 3 is being multiplied to the x, I need to divide it to move it to the other side. So I'd be dividing here or multiplying by the reciprocal. So we would get x is equal to pi over 18, and x is equal to 5 pi over 18. So these would be our 2 answers. For 18, again, doing the same thing. Our trig function's already by itself, so I need to figure out where sine is 1, where the y value, because sine tells us we have to look at the y value, so where our y value is 1 on our unit circle. So 4x is equal to our y value is 1 at pi over 2. And that is it. So I need to get that x all by itself. I would divide both sides by 4 or multiply by the reciprocal. So we would get pi over 8. And that would be our only answer here. All right, we did 19 in class. Our u is 100 and v is 70. So tangent of 100 minus 70. So that would be tangent of 30. Tangent tells us we have to look at what? Y over x. So go to 30 degrees on your unit circle. And what is y over x at 30 degrees? Perfect. You end up with 1 over square root 3, but we always have to rationalize. So it would be square root 3 over 3. So this would be your answer.
All of them would be your answer?
Yes, because it says write its expression as a single trig function. Miss Meta spelled it wrong. And find the exact value. So both parts. So 20, we want to use the sum and difference formulas to find the exact value. These are not on the unit circle. One of them is. They are both on the unit circle. Perfect. So what would I need to do first? I'm going to plug it into the formula. So I have the cosine and minus 1. So that would be cosine of u times cosine v plus sine u sine v. And we can just make our first one u and the second one v and plug them in. So my formula would be cosine of 11 pi over 6 times cosine of 3 pi over 4 plus sine of 11 pi over 6 times sine of 3 pi over 4. So on the unit circle, what is my coordinate point for 11 pi over 6? It would be square root 3 over 2 and 1/2, negative 1/2. And then on my unit circle for 3 pi over 4, my point would be negative square root 2 over 2 and square root 2 over 2. So cosine tells me I have to look at what value on the unit circle? X. So cosine, I'm looking at the x's. Sine, I'm looking at the y's. So I'm looking at 11 pi over 6, and my x value would be square root 3 over 2. Then I need to look at 3 pi over 4, and my x value would be negative square root 2 over 2. Everybody with me so far? Okay. So then sine of 11 pi over 6, I'm looking at the y value, would be negative 1/2. And then times the sine of 3 pi over 4, which would be the y value here, so square root 2 over 2. Now when we multiply fractions, we multiply straight across. So what's square root 3 times negative square root 2? Negative square root 6 over 4, perfect. And negative 1 times square root 2 would be negative square root 2 over 4. And I can combine these together, so it'd be negative square root 6 minus square root 2 over 4. So what would I have to do first to find my two numbers for number 21? Convert it to degrees. So I'd multiply it by 180 over pi. The pi's cancel. I'm not quite sure how many times 12 goes into 180, but I do know 6 goes into both of them. So this would be 2, and 6 goes into 180 30 times. So then 2 goes into 30 15 times. So I have 15 times 11. So yeah, these are big numbers, but we can write it down and figure out what 15 times 11 is. So this would be 165. Nope. So it's 165 degrees. Now what two angles will either add up or subtract to 165? 135 and 30. That works. So we could say 135 and 30. Did anybody find anything different? 120 and 45, that would work. So you just need to find one, and then this would be your U and your V, and plug it in just like we did in 20. But whichever one you use, you'll end up with the same answer. All right, so let's do it using 135 and 30. So this is going to be my U and my V. So my formula for the sine and the plus 1 will be sine of U, so sine of 135, times cosine of V, so cosine of 30, plus cosine of U, so cosine of 135, times sine of 30. Now my coordinate point for 135 is negative square root 2 over 2 and square root 2 over 2. And then my coordinate point for 30 would be square root 3 over 2 and 1/2. So sine tells me I have to look at what values? Y, cosine is x. So sine of 135 would be what? Square root 2 over 2. And cosine of 30? Square root 3 over 2. Plus cosine of 135 would be the x value. So negative square root 2 over 2. And sine of 30 would be the y value, so 1/2. Then we just got to multiply them together. So this would be square root 6 over 4 plus negative square root 2 over 4. So it'd be square root 6 minus square root 2 over 4. All right, let's do 22. So it's the one that goes cosine, cosine, and minus. So we're looking at the formula that has cosine, cosine, minus. So that would be cosine times U plus V. So the first number is going to be your U. The second one is your V. So this will be cosine of 50 plus 10. So cosine of 60. Now this is part of your answer. You need this. You need to see that you know that it's cosine of 60, but we also need to figure out what the cosine of 60 is. We have to evaluate it. What is the cosine of 60? 1/2, perfect. So we're looking at the x value at 60, which would be 1/2 on our unit circle. So this would be our answer. We need to figure out which formula goes sine, cosine, and minus. So which of our sum and difference formulas goes sine, cosine, and minus? So sine of U minus V. So this is our U, and this is our V. So this will be sine of 315 minus 15. So sine of 300. So this is part of our answer. We need to figure out what the sine of 300 is. So I go to my unit circle at 300, and what is my y value? Negative root 3 over 2. Perfect.
Will we ever get something that's not exactly on the unit circle?
No. For these type of questions, it'll be something on the unit circle. So let's do 25. All right, so we need to figure out our two triangles. We have alpha and beta, which is the same as just saying U and V. They just have different names here, but that's fine. One of them's U, the other one's V. On the test tomorrow, it's not going to say quadrant 1. It'll say from 0 to quadrant 1 would be to pi over 2. One way that you can figure out if it gives you from 0 to pi over 2, go to your unit circle. All right, so let's look at our first triangle, alpha. So it's going to be in the first quadrant. Sine is what over what? Y over r. So I know my y is 3 and my r is 5. How did I know that this side of my triangle is going to be my y? Because that's the y-axis. Y goes up or down. So what am I missing? X. So I need to figure out what x equals. How do I find what x equals? Pythagorean theorem. So I'm going to say x squared plus 3 squared is equal to 5 squared. If you know this is a Pythagorean triple, so when you work it out, you'll get 4. So 3, 4, 5 will always be a right triangle. If 2 of your sides are 3 and 4, you know your hypotenuse is 5. But you can work it out using Pythagorean theorem if you didn't know. So x is 4. Is it positive 4 or negative 4? How did you know it's positive 4? It's in quadrant 1. It's going in the right direction, so it's going in the positive direction on your axis. So x is 4, y is 3, r is 5. Yeah. So just always double check your signs. The r will always be positive. So this is our important information for our alpha triangle. Now we need to do the same thing for beta. So beta is in quadrant 3, which would be this one down here. Sine is what over what? Y over r. Does the negative go with the y or with the r? The y. So this would be negative 12, our y, because that goes up or down. And r is 13. And I need to find my x. Here we have another Pythagorean triple. So what's x going to be? 5. Positive 5 or negative 5? How did we know it's negative 5? Because it goes to the left in the negative direction, and it's in quadrant 3. So x is equal to negative 5, y is equal to negative 12, and r is 13. So this is all of our important information for beta. Now it tells us we are using our formula, cosine of alpha plus beta. So I'm going to go to my sum and difference formulas and use my cosine adding 1. So that'll be cosine of, instead of u, I'm just going to use alpha. So cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Cosine, we have to look at what values? X over r. Cosine would be x over r, and sine is y over r. So I'm looking at my alpha triangle, the pink one. X would be 4 and r is 5. So we have 4 over 5. Now I need to look at my beta triangle, the blue one. What would cosine of beta be? Negative 5 over 13. We just do the x over r. Then we have minus. Going back to the alpha, what's sine of alpha? It would be 3 over 5. And then what's sine of beta? What is it? Negative 12 over 13. Be careful with your signs. So then we just want to multiply them and subtract. So we get negative 20 over 65 minus negative 36 over 65. When we subtract negative, we add. So what would we get? 16 over 65. And that would be our answer. Let's say, so neither one on the review is this, but let's say you were given tangent of, we'll say u, is equal to negative 3 over 4, and you are in quadrant 2. Tangent is what over what? y over x. How do I know which one the negative's going to go with? I need to figure out, I'm in quadrant 2, so over here. So my y is 3. Is the negative going to go with the y? It'll go with the x because I'm going negative left, so the x will be negative. I'm going up, so the y is positive. So the negative goes with the 4.
Change the signs. Because the 3 is,
Well,
well, the negative 3 is
it'll be out front, so it'll be like this. So you'll have to figure out which one it goes with. Let's say I had the sine of 415 degrees. And this is just like number 21. So an example like 21, just different. What would I do? I can subtract 360, find the coterminal angle of it. So what would we get? So sine of 55. And then I need to figure out what two angles on the unit circle add to 55. So what would that be? Or add or subtract?